Okay, I'm noticing that students are having problems with composite shapes and finding the area of composite shapes. So I'm going to make a video on it. Uh, we're going to just do three shapes. So this will be the first one. This will be the second one. And then the third one is going to be an actual field from, like what a farmer would use from Google Earth. So here's the actual field. You can kind of see I just mapped out. It's actually one of mine. So something that what's the area of this field that a farmer would have to deal with. So you don't have to necessarily stick around for that third one, but if you're interested in how you would do this and apply it to some real life situation, I mean, this is one example. There's many, but this is one. So here we go. We'll get started. Here, I tell all my students is you pretty much cut everything into either a rectangle or a triangle or a circle. So those three are the main three that get you by pretty much for almost every situation until you get into the complex stuff. And this is a fairly complex problem. There's a lot of shapes inside of here. And so what I would do is pause the video and cut this thing into rectangles and triangles. Yours might be different than mine, but that's okay. There's different ways to cut this thing up. But I'm going to go ahead and cut it up now. And so here's what we have. The way I would like to cut this thing up is I kind of like this one here on the right side because we already know. So this this rectangle is a 17 by 3, and so area of a rectangle is length times width. I think you learned that clear back in the 4th grade. So it's kind of something you've probably got memorized. If not, it's easy to memorize it quickly. So that area is 17 times 3. And so if you do that, 51. Pretty sure. You can check my math because I do make mistakes just like you do. The other area, this side over here, on the left side, a little trickier because we've got a little, looks like a slanted part. So what I'm going to do is cut that kind of complex looking part off. That's because we've got another rectangle then. And we know that this side has to be 9. And let's change colors. So because that side's 9, we know that the left side's 9 because triangles are equal to each other on opposite sides. Opposite sides of a rectangle, are equal. So this is 9, that's 9. The only thing we've got to find then is this length. It is not 25 because 25 goes all the way to the other end. Well, we know this side is 3 because this side is 3. And so if you just subtract 25 from 3, we know that this is 22. So now this blue rectangle is 22 times 9. And 22 times 9 would be 18, 19, 198. And again, check my math to make sure I'm right. So far we've got 2 rectangles. One's 51, one's 198. And all that's left is this bottom shape. Now, this shape is a trapezoid. So we could use the formula for trapezoid. However, maybe you don't have the formula for trapezoid memorized. It's kind of complex. You don't need it. So what's kind of nice is you could just cut it into another rectangle, and we got a triangle. Triangle's a little tougher. Its length is a rectangle cut in half, so it's length times width divided by 2, or we usually say base times height divided by 2. And so now instead of a trapezoid, we've got 2 simpler figures. We've got a triangle and another rectangle. Well, this side, we'll do it in red here. That's 5. That's nice. But we don't have this length. So that's going to be a problem. So we don't have the height or the width or whatever you want to, length times width. Sometimes you see it as base times height. Either way, it works just fine. Now, we do know, though, that this up here is 9, and we know from the other side of the shape that that's 17. And so we can just subtract those, and this would have to be 8 then. 17 minus 9 is 8. Okay, now we need to figure out this length, which that's kind of nice because it's 5, is straight across. And so we know that this area of that rectangle is 40, 8 times 5. Then the triangle, and let's see, what color don't we have? We got blue, green, black. Yeah, we'll just do black. So we'll do the triangle in black. And what's nice is this is 8, and this length, we're always looking for where they come out with 90 degrees. We don't have. Well, we've got an 11 here. We've got 22 from that blue one. So if you take 22 minus 11, that would give us 11. And then if you take 11 minus the 5, this 5 here, that gives us 6. And so that tells you that length. You just subtract off the ones that you have to find the missing one. And so this triangle, if you take base times height divided by 2, would be 8 times 6 divided by 2. And that should give you 24. So there's another area. So this is 24, this is 40, 198, and 51. So now all that you have to do is add those together. So let's go ahead and add them. So you'd have 198 plus 51 plus 40 plus 24. And you add all that together, and you do get 313. But again, double check me. I could have made a mistake there. Math teachers make mistakes too. It happened. It's not a big deal. You just go back and fix them. That's where you learn, from those mistakes. So the area of this, and probably make sure you put a label with it, since they told you it was centimeters. It is 313 centimeters squared. And we've done that one. So now let's look at the next problem, which might be just a little harder. And again, I encourage you to pause the video. I didn't mean to put that 3.2 there, but it wasn't there to start with. But it is 3.2 because of these marks. So that is, we call them tick marks in geometry, and they represent congruent or equal lengths. So if that's 3.2, that means this length is 3.2. And that's going to be important. We're going to need that. If we don't have it, we can't solve this prop shape. The other thing, we'll go ahead and split this thing up and into a hemisphere, or a half circle. So we've got a half circle up here. I'll just trace it in black. So we're going to figure out that half circle. So we're going to need the area of a circle, which that's another one I encourage you to memorize. And you'd have a trapezoid on the bottom. Again, I like to avoid trapezoids. You'll need them in calculus. When you take calculus, you'll need that trapezoid area memorized. But until then, rectangles, triangles will do you just fine. So I'll split that thing into a rectangle and a triangle. And this has to be 2.5 because this side's 2.5. So this area and this length is 3.2 because it's the radius of a circle. So that means this whole diameter, or the length of the rectangle, is 6.4. So we could calculate the area of this rectangle real easy, and that is 6.4 times 2.5. Multiply the 6.4 and 2.5, you get 16. Again, I encourage you at this point to use a calculator. Concentrate on the math and not silly mistakes you make by doing this stuff by hand. You'll make enough mistakes without it. So use a calculator to kind of help you out. So 6.4 times 2.5 is 16. We just need to let's find the area of this triangle next, and we'll do the circle last. This triangle has an interesting problem in it, in the fact that we don't know that length. This is a problem. And if you've never experienced solving for the length of a missing side of a right triangle, that takes a whole nother topic in math, kind of the it's like a club for problem solving. It's Pythagorean theorem. A squared, if you've got a right triangle, Pythagorean theorem says a squared plus b squared is equal to c squared. If you're talking about the lengths, we're not going to get into all the fun stuff that's involved with it. We're just going to use it. Where the legs of the triangle are a and b, and the hypotenuse is c. And you may not know all those terms yet. It's okay. You just have to know that the longest side is always c, and 3.2 is the longest side. So if we plug this into that formula, you would have 2.5 squared for a plus b squared, we'll just call this question mark a b, equals 3.2 squared. And again, let's get a calculator out. You might have 2.5 squared memorized. It's kind of a one that's used quite a bit, but it's 6.25 plus b squared equals 3.2 squared, which is 3.2 times 3.2 is 10.24. Like I say, I encourage you to use a calculator. Then subtract the 6.25 to get b by itself. So you got to do a little algebra with this one. It's kind of a hard one. So 10.24 minus 6.25. Whoops, I just did it wrong. Like I say, I'll make mistakes just like you do. Gives you 3.99, which is almost 4. So I know b is almost 2, but we're going to take the square root of 3.98. I would encourage you to, you've got b squared equals 3.99, so you have to eliminate the square, you have to square root both sides. And so the square root of 3.99 is almost 2. It is so b would be 1.997. When you're entering these in computer, like Khan Academy and places like that, I would save all your rounding until the very end. And so this is 1.997. You could probably use 2 and be just fine, but we're going to go ahead and do all the decimals in case you have to enter this into a computer platform and they freak out because you get it wrong because you're a tenth off or something silly like that. So the area of the triangle now is base times height. So 2.5 is the height times my base, 1.997, all divided by 2. So the area of that thing, 1.997 times 2.5 divided by 2. Again, use a calculator, 2.496, 25. Again, you could add more decimals. We don't really want to do a whole lot more than that. That should be plenty if you're entering them into a computer entry thing. The last area left, then, is the circle. So if you go in here, we've got to find the area of that half circle. Area of a circle is pi times your radius squared. And so our radius is 3.2. So the area of the circle is pi times 3.2 squared. And then you have to divide that by 2 because it's half of a circle. So again, I would get a calculator out and do that. So pi, and I would use the pi key on your calculator, or if you use an online calculator, Desmos has a good one. But use the pi key if you can. So pi times 3.2 times 3.2 is 32.16, and then you divide that by 2. And we'd have 16.08. Usually you have to round to the nearest hundredth. So on the Khan Academy and places like that. So we got 16.08 is one of my areas. So we got 16 plus 16.08 plus 2.496 is probably just fine. And so when we add all these together, you would have 12, 13, 14, so 20, 30, see, there you go. So 34.5, and I'm kind of adding ahead of time here. So 9 and 8 is 17, you know, so 34.576. So, you know, if you're probably entering this online, you're looking at maybe a 34.6, or maybe you have to enter to the hundredths, so 32.5 or 34.58. But that's your area. And there you go. That was kind of a tough one. So again, I'm going to finish with this last video. Is already 15 and a half minutes long. I hate to go much longer than that, but I will do this really fast. I'm going to just quickly go in and show you. What's nice about Google Earth is they have a ruler up here, and I'll just drag it down. If you hit that ruler, this is what you get. And we probably, since we're dealing with huge lengths, we probably want feet or yards. I'm going to go feet for the most part. And I'll just show you quick. If you wanted to find, say, this length along the top, you just click, go across, and now you know that whole length across the top. And I don't think I'm going to do this whole thing, but I will show you how I would break it up if I really was going to do this. So if I was going to do this field, and here's the picture, you know, and as a farmer, I would probably break it here and calculate this rectangle length. I would break it here and calculate this area, this length. I would break it here, calculate this length, and you know, just grab those links from Google. You just need this length and this length here. So this is your height. You'd need this length here. So the X's don't mean anything. I'm just showing you the rectangles. I would calculate the area of this triangle down here and then go straight up, probably. I wouldn't go across. So then you'd have to find the area of this triangle, the area of that rectangle, and then if you did this field, looks like we've got a square with a little triangle at the bottom. And so you would have, those would be all of those we do. And if you look at this bottom, it's not a perfect rectangle. So if you wanted to get really good accuracy, you'd probably want to put that triangle in and find those, you know, here's your base, here's your height, and here's your right angle. So, and find that little chunk on the bottom. And so you've got, this is a pretty complex problem. It would run me into about 30-minute video. So finding all of these, and I don't want to, you won't watch it anyway. So here it is. So if I were to do this, that's how I'd break it up, and then find each of those and then add them together. So very powerful. I hope this video helps. See you next time.